So you, Tim, you have a PhD in agronomy from the University of Madison.
Yep.
Agri-Tech Consulting is the name of the firm here.
Yep.
So we're on.
I have a degree in agronomy. I have a minor in plant pathology and a minor in soil science. So I always tell people, don't ask me too much specific, but I can handle this much. My scope is agriculture is about the big picture, not just the micro picture. And we might have a treatment that looks great, but it's got to work with everything else going on. This isn't a greenhouse out here. This is real world.
And thank you for the good work that you do out here. I think what I've learned over the years is that it's really hard to find someone that does good on-farm field research. So I wanted to start by just asking you, tell me why research here is different than in a lab or on an on-farm trial.
Well, a lab only allows you to do so many variables, and the crux of the lab is to control every variable so you're only testing the one that you want. So you sterilize soil, you have perfect soil moisture, you have perfect waterfall, you have perfect daylight. I mean, you want to set for 12 hours of daylight or 14, you can dial it in perfectly. But the hope is that something settles out that you can then go further. Greenhouse is great to do a lot. You could do in flower pots, you could do 100 treatments in a space that's 10 by 10. Well, that's only good for a greenhouse.
Sure.
You want to set it up like a field trial, so it's in a field, you've got proper weed control, but you don't control the environment because you do want the environment to be part of the study, not controlled so tightly. So right. You'll have drought spells, you'll have heavy rain spells, but that's real life.
Right.
That's why on-farm can be such an important tool to learn how something works.
Right. You talk about almost the reductionist theory in the lab where they try to isolate one thing. We know that's not the way it is in farming. And the other thing is, I mean, the trial last year was, I think, 27 different treatments and all the replications. You just really can't get that kind of detail, gather that kind of information.
Well, it's crazy. You have to have kind of that kind of mind to be able to manage those kind of numbers. But think about this though. In the BMP, your best management practice is not a greenhouse. Greenhouse is controlling everything, but in a field, you want to try to put your best management practice to use. Weed control, timelines. I mean, the timing, the genetics, the soil fertility, the hope for frequent rains. You're putting your best foot forward, not trying to save yourself to prosperity. Like, where can my inputs be best spent to have the best yield that I can?
Right, BMPs. You talked about that last fall when we were in the field. Let's go back and take a look at what we did last year in the field.
There's two ways of doing research, and there's two ways of doing crop production. You can basically take everything out to try to get a halfway decent yield, or you can see what you can put into it to get a really good yield. And I've always been, bet your BMP or your best management practice should be pour the coals to it. I mean, I don't mean throw billions of dollars to it, because economically that'll only go good for 1 year and then you're done. But you want to place the money where it's going to give you your best return.
In the trial that we just viewed,
Yes.
in the segment, when you isolated all the in-furrow trials, CX1 was the top performer. When you looked at the trials that were both in-furrow and side dress, again, in the words of the lead agronomist, that was the highest performing treatment, tied with another at the top.
It was.
Prior to that, a very large agribusiness company worked with you, and again, they chose CX1 into their mix because their portfolio, because of the way it outperformed others.
Well, when a large company decides to choose something, they don't choose it because they think it's a good choice. They choose it because they've seen that it is a good choice. There's a big difference in that.
Sure.
This isn't just like marketing bubblegum or something like that. You need to see it. You need to see it in the yield. And I understand we can take drone shots, we can do everything we want to. None of those really are that important to me. I want to see what the combine says. If the combine says it, all that other data supports it. If the combine doesn't say it, it's not there. We saw the combine support those treatments.
So why do you think CX1 performs so well?
I could give you 1,000 reasons, probably 900. I'm not really sure why. And one honest reason is I don't know.
Yeah.
I do know that biologicals are important in growing crops because we are growing crops in a soil, and a soil has nutrients, but that's only part of it. It has life through the microbes, good and bad. I mean, good and bad, because you need microbes to break down residue. You need microbes to convert what can't be used to something that can be used. You need microbes hold fertility until the plant needs it. You need microbes to keep the plant roots healthy. You have that rhizosphere. They work essentially with the plant. Well, why does CX1 work? It works with the plant. When we're growing a crop, it isn't just, well, I have so much NPK, I know I have good corn. Well, yeah, but it isn't just NPK. There's the macros, there's the micros. Those are important. It's your soil pH, your base solubility of P and K. It's the microbes that are working with the crop to solubilize nutrients for crop growth. They all work together.
Right.
So why does CX1 work? Well, I think it's doing something. And I'm being vague on purpose because I don't know exactly, but I do know that microbes, and I've looked at the material, you open the jug, it's good. There's not solids in there. It's a high quality product where that's a start. So I'm not plugging screens, I'm not plugging tubes. I put it on, it goes on. It's working with the plant to turn the yield on, basically.
And this is kind of where we started the conversation today. Microbes do so many things. Farming is about so many different things. It's never just about one thing.
Right.
So having a product that has such a wide diversity means you get a broad array of biological functions.
Okay, why did the corn in that trial do well yesterday, or that last year? Why did it yield well? Yes. Did we have good weather? We had good weather. I didn't think it was ideal.
Yeah.
We had almost 10 inches of rain in July.
Yeah.
That's not when I want that much rain.
Right.
So was it the weather? Well, the weather was conducive to crop growth. We had decent heat units conducive to crop growth. We had good soil conducive to crop growth. We split applicated our nitrogen, a very positive effect. We were adding microbes, a very positive effect. We had good genetics, a good positive effect. So it wasn't that I could say, well, we had great weather. I don't think last year's weather was great. It was better than the couple of years before that. It was good weather.
Right.
So that was only part of it. What else did we do? Well, with farming, we put the pieces together.
Organic fertility with 260 bushel an acre corn,
Yeah.
that's pretty impressive.
Well, I think so.
Yeah.
We did not mind harvesting that corn.